Hello my dear friends, once again welcome all of you in our PM online channel. Today we start our next chapter of Math Second and it is chapter number 3rd, Circle. What is circle? Friends, you know that the set of points equidistant from a fixed point in a plane is called as a circle. Before starting our chapter, first you should know some basic concept of circle and in which first one is congruent circle. What is congruent circle? Friends, circles which coincides exactly are called as congruent circles. And when circles are coincide exactly, friends, if the two or more circles have same size, and then only two or more circles are coincide with each other, and such a circles are called as congruent circles. And this size, we can measure this size either in radius or in diameter or in circumference. It means that, friends, if the two or more circles have same radius or same diameter or same circumference, then that circles are called congruent circles. For example, here we have two circles, first circle with center A and second with center B. And clearly here radius of first circle is 2 cm and radius of second circle is also 2 cm. So these two circles have same size as they have same radius, and hence these two circles are congruent circles. Topic is concentric circle. What is concentric circle? Friends, when the two or more circles having common center, then such a circles are called as concentric circle. For example, here we have two circles. First circle having radius 1 cm and second circle having radius 3 cm. But these two circles having a common center and which is center O. So these two circles are the concentric circles. A very interesting topic is intersecting circles. What is intersecting circles? Friends, when the two circles are intersects each other, then that circles are called as intersecting circles. For example, here in first figure there are two circles, first circle with center A and second with center B, and these two circles are clearly intersect in this single point O, and hence these two circles are intersecting circles. In second figure there are also two circles, one circle with center C and second with center D, but here these two circles are intersect in two distinct points, point P and point Q. So these are also intersecting circles. Here you should always remember that when two circles are intersect either in a single point or more than one point, then that circles are called as intersecting circles. Let us recall some properties of chords studied in previous standard, in which first property is a perpendicular drawn from center to a chord bisect the chord. It means that any perpendicular drawn from center of circle to the chord, then that perpendicular makes two equal part of that chord. For example, here in this figure, a perpendicular drawn from center of circle, that is point O, to a chord at point B, then this perpendicular OB makes two equal part of the chord, that is AB equals to BC. It means that this perpendicular OB bisects the chord, and hence a perpendicular drawn from center of circle to the chord bisect the chord. Then our next property is nothing but the converse of first property, and it is a segment joining the center of circle and midpoint of its chord is perpendicular to chord. For example, here in this figure, O is the center of circle and B is the midpoint of chord AC. So a segment joining the center of circle and midpoint of chord is perpendicular to chord. That is, the segment OB is perpendicular to chord AC. The property is the chords of circle equidistant from center of circle are congruent. For example, here O is the center of circle and AB and CD are the two distinct chords of circles, and clearly here chord AB and chord CD are equidistant from center O, that is these two chords are at equal distance from center O, and hence these two chords are congruent, that is chord AB congruent chord CD. Then our fourth and last property, which is the converse of third property, and it is the congruent chords of circle are equidistant from center of circle. For example, here O is the center of circle and chord AB and chord CD are the congruent chords of circle, and hence these two chords are at equidistance from the center of circle. That is, these two chords AB and CD are at equal distance from center O, and hence OP is equal to OQ. Our next topic is circles passing through 1, 2 or 3 points. Friends, always remember that first one, there are infinite number of circles can pass through one point. Second one, there are infinite number of circles can pass through two distinct points. Third one, there is one and only one circle passing through three non-collinear points. And fourth and very important one is no circle can pass through three collinear points. Then next is tangent of the circle. What is tangent of the circle? Friends, if a line and circle have one and only one point in common, then such a line is called as tangent of circle, and that common point is called as point of contact. For example, here in this given figure, since point P is the only common point of circle and line M, so line M is the tangent of the circle and point P is the point of contact. Next is secant of circle. What is secant of circle? Friends, if a line and circle have 2 points in common, then that line is called secant of the circle, and that common points are called points of intersection. For example, here in this given figure, point A and point B are the 2 points which are common in circle and line L. So line L is the secant of the circle and point A and point B are the points of intersection. Then our first theorem of this chapter is tangent theorem. What is tangent theorem? Friends, a tangent at any point of a circle is perpendicular to radius at the point of contact. And friends, as this theorem is for your more information, so proof of this theorem will not be asked in your exams. But the statement of this theorem is useful for us to solve the examples on it. Then our next theorem is converse of tangent theorem. What is converse of tangent theorem? Friends, a line perpendicular to a radius at its point on the circle is a tangent to the circle. To prove this theorem, here we have given that M is the center of circle. This point M is the center of circle. Segment MN is the radius, and this segment MN is the radius of circle, and also line L perpendicular to segment MN at N, and this line L is perpendicular to segment MN, that is which is the radius of circle at point N, and we have to prove that line L is a tangent to the circle. This line L is a tangent to the circle. To prove this theorem, first we have to take any point P on line L. So we take this point P on line L and then draw a segment MP. Then here we have given that line L is perpendicular to segment MN at N. This line L is perpendicular to segment MN at point N. So this triangle MNP is a right angle triangle. So in triangle MNP, angle N is a right angle. And as this triangle MNP is a right angle triangle, clearly this segment MP is the hypotenuse. Therefore, segment MP is the hypotenuse of right angle triangle MNP. Now we know that the hypotenuse of any right angle triangle is the largest side of that triangle, and hence this hypotenuse MP, that is segment MP, is greater than this segment MN. Therefore segment MP, which is the hypotenuse, is greater than the segment MN. And friends, as this MN is the radius of circle, so this point P can't be on circle, as segment EMN is radius. This point P can't be on circle. Point P can't be on circle. And this is also true for all points except N. It means that line L intersect the circle in only point N. Therefore, line L intersect circle in only point N. And friends, we know that when the line and circle have only one point in common, then that line is called tangent of circle. And here this line and circle have only one point in common, that is point N, and hence this line is the tangent of circle. And therefore line L is the tangent of circle, and hence our theorem is proved. Then our next theorem is tangent segment theorem, which is given us in the form of activity, and it is a tangent segments drawn from an external point to a circle are congruent. What? The tangent segments drawn from the external point to the circle are congruent. To prove this theorem, here we have given that A is the center of circle, point A is the center of circle, and lines DP and DQ are tangents to the circle at points P and Q respectively. And this line DP and DQ are the tangents to the circle at point P and Q respectively. And we have to prove that segment DP congruent segment DQ. That is, this segment, that is tangent DP congruent segment DQ. To prove this theorem, first we have to draw segment AP and segment AQ, so that we get here two triangles, triangle PAD and triangle QAD. Now in these two triangles PAD and QAD, first segment PA congruent segment QA. Why? Because radii of same circle. So we write here segment PA congruent segment QA, radii of same circle. Then segment AD congruent segment AD. Why? Because this is the hypotenuse of two triangles and also common side of both the triangles, and hence segment AD congruent segment AD, which is the common side of both triangles. Then angle APD congruent angle AQD. Why? Because both of measure 90 degree. Both of measures 90 degrees. So these two angles are congruent, and hence angle APD equal to angle AQD is equal to 90 degree according to the tangent theorem. Because these two lines are the tangents to the circle, and according to the tangent theorem, these two angles, angle APD and angle AQD are of measure 90 degree, and hence both are of measure 90 degrees. So these two angles are equal, and hence our triangle APD and triangle AQD are the congruent triangles by hypotenuse side test. And friends, we know that when two triangles are congruent, then their remaining sides and angles are also congruent, and hence here this remaining side DP congruent side DQ, that is segment DP congruent segment DQ, and hence our theorem is proved. Let us solve some examples from our practice set 3.1, and in which our first example is, in the given figure the radius of circle with center C is a 6 cm, line AB is a tangent at A. Answer the following questions. Here we have given one circle with center C having a radius 6 cm, and this line AB is a tangent to the given circle at point A. And we have to answer the following questions, and in which our first question is, what is the measure of angle CAB and Y? To solve this question, first we have to draw segment CA. So draw segment CA. And friends, we know that according to the tangent theorem, tangent at any point of circle is perpendicular to the radius at point of contact, and here this tangent is perpendicular to this radius, and hence the measure of angle CAB is 90 degree, because this angle CAB is a right angle, and therefore angle CAB is of measure 90 degree according to the tangent theorem. Then our second question is, what is the distance of point C from line AB and Y? What is the distance of this point C from this line AB? Friends, according to the tangent theorem, this segment CA is perpendicular to line AB. Segment CA perpendicular to line AB, and clearly this segment CA is the radius of circle, and we have given that the radius of circle with center C is 6 cm, and hence the distance of point C from line AB is 6 cm. Therefore the distance of point C from line AB is 6 cm. Then our third question is, distance AB is 6 cm, then find distance BC. To solve this question, first we have to draw a segment CB. Now here we have this distance, that is segment CA, which is nothing but the radius of circle. So this segment CA is 6 cm, and we have also given that distance AB is a 6 cm. So this distance AB is a 6 cm, and we have to find distance BC. That is, we have to find this distance BC. Friends, we also know that this angle CAB is of measure 90 degree. So in triangle CAB, angle A, that is CAB, is of measure 90 degree. So this triangle CAB is a right angle triangle, and hence according to the Pythagoras theorem, by Pythagoras theorem, we can find the value of CB. What is our Pythagoras theorem? According to Pythagoras theorem, CB square, square of hypotenuse, is equal to sum of the square of remaining two sides, that is CA square plus AB square. And what is the value of CA? 6 cm. So 6 square plus value of AB is also 6 cm. So 6 square plus 6 square. 6 square plus what is 6 square? 36 plus 36. 36 plus 36, 72. So we get CB square is equal to 72. By taking square root on both sides, we get CB is equal to under root 72, which can we also write 36 into 2. What is the square root of 36? 6 is the square root of 36, and hence we get the distance CB is equal to 6 under root 2 centimeter, and hence the distance BC is equal to 6 under root 2 centimeter. Fourth and last question is, what is the measure of angle ABC? It means that here we have to find the measure of this angle ABC. Friends, in triangle ABC, we know that AB is equal to AC. Why? Because both are of equal measures, that is 6 centimeter. So AB is equal to AC. And friends, we also know that when the two sides of any triangles are equal, then that triangle is isosceles triangle. And according to the theorem of isosceles triangle, these two angles are also equal, and therefore angle ACB is equal to angle ABC according to the isosceles triangle theorem. Now to find this angle ABC, first we have to let these two angles of measure x degree. So let angle ACB equals to angle ABC is equals to x degree. Now we also know that the sum of the three angles of any triangle is 180 degree, and in triangle ABC the sum of these three angles is 180 degree. So therefore in triangle ABC, angle ACB plus angle ABC plus angle CAB is 180 degree. And we know that AC, and we suppose that ACB and ABC is x degree. So put ACB is x degree plus ABC is also x degree, and we know that CAB is of measure 90 degree because this angle is a right angle. So CAB is a 90 degree is equal to 180 degree. X degree plus x degree is 2x degree plus 90 degree is equal to 180 degree. Therefore 2x degree is equal to 180 degree minus 90 degree. Therefore x degree is equal to 2x degree is equal to 90 degree, and therefore x degree is equal to 90 degree upon 2. Therefore x degree is equal to 45 degree. And we suppose this ACB and ABC is x degree. So measure of angle ABC is equal to 45 degree. And friends, now you can easily solve the remaining examples of our practice set 3.1. Thank you.